Connectors and fiber terminations. Connectors are removable joint which allow easy, fast manual coupling and uncoupling of fibers. Demountable fiber connectors are more difficult to achieve than optical fibers. Requirements of good connectors. First one, during connecting joint, it should offer low coupling loss. Connectors of the some type must be compatible from the one manufacturer to another. In the fiber link, the connector design should be in a simple manner so that it can be easily installed. Connector joint should not be affected by temperature, dust and moisture, that is, it should have low environmental sensitivity. Fiber connectors may be separated into two broad categories: put joint connectors and expanded beam connectors. Put joint connectors further classified into two types: cylindrical ferrule connectors and double eccentric connectors. Cylindrical ferrule connectors. The basic ferrule connectors is the simplest optical fiber connector design. The two fibers to be connected are permanently bonded with epoxy resin in metal blocks known as the ferrules, which can accurately build central core in either end faces. The ferrules are held in the place via a retaining mechanism, which is the spring. It is essential that with this type of connectors, the fibers end faces are smooth and square, that is perpendicular to the fiber axis. Expanded beam connectors. This connector device interposed optics at the joint, that is lens, in order to expand the beam from the transmitting fiber end before reducing it against a size compatible with the receiving fiber end. Here the connectors consisting of two lenses for collimating and refocusing the light from one another to the other. Working. The connectors shown utilize two spherical micro lenses for beam expansion and detection. This exhibited average losses of 1 decibel, which are reduced to 0.7 decibel with the application of an anti-reflection coating on the lenses and the uses of 50 micrometer core diameter graded index fiber. Double eccentric connectors. These connectors does not depend on a concentric fixed sleeve approach. The mechanism used here is of archive assembly approach. It consisting of two eccentric cylindrical within the outer coating. It is observed from the diameter that the optical fiber is mounted eccentrically with the inner cylinder. This operation is performed using either an inspection microscope or a peak optical adjustment. Next one is the optical sources. The requirements of optical source used for communications are: it must emit the required wavelength of 1.3 micrometer and 1.55 micrometer in case of optical silica fiber. Second one, the spectral line width of the source should be small as possible, nearly 1 nanometer, because dispersion is directly proportional to the spectral line width of the source. The light source should have compact size and high efficiency. It should be reliable, durable, and inexpensive. It must require very small time for its operation. The materials: semiconductor, laser diode, and the LED light emitting diode. Among the semiconductor, only direct band gap semiconductors are used. Direct band gap is one in which the conduction band electron can recombine directly with a hole in the valence band. Laser type. The first one is a homojunction laser and the second one is a heterojunction laser. In homojunction laser means that a PN junction is formed by a single crystalline material such that basic material has been the same on both the side of the junction. Heterojunction laser means material on one side of the junction differ from that on the other side of the junction. Operations of the laser diodes are absorption, spontaneous emission, and the stimulated emission. GAA is laser diode. A layer of GAA is sandwiched between the two layers of GAALAS. Charge injection takes place into the active layer. Spontaneous emission of photon is produced. Some of the injected charges are stimulated to emit other photons. Next one, light emitting diode. Here PN junction diode is operated under forward bias. Under forward bias, majority carriers flows both sides of the junction cross the internal potential barrier and enter the material at the other side where they are called minority carriers. This causes the local minority carrier population to be larger than normal. This is called minority carrier injection. The types of LEDs are surface emitting LED and the edge emitting LED. In surface emitting LED, a layer of GAA is sandwiched between the two layers of GAALAS. GAAS layer, it is the form of the cylindrical region. This region is 20 to 50 micrometer in diameter. So, to couple fiber with LED, fiber core diameter greater than 100 micrometer is highly suitable. Edge emitting LED can consist of the three parts: confinement layer, metallization, SiO2 isolation layer. The length of the active region is 100 to 150 micrometer. So 50 to 100 micrometer cores can be matched with these LEDs. The emission pattern of the edge emitting diode is more directional than that of the surface emitting LED. Next one is a photo detector. It is a device used to convert the light signal to electrical signal at the receiver end of the fiber link. The requirements of photo detectors are high quantum efficiency, that is a conversion efficiency, low dark current, signal dependent noise should be low. PIN diode. PIN is positive, I is the intrinsic, N is the negative photodiode. This consisting of P and N region separated by a very lightly n-doped intrinsic region. In normal operation, the PIN photodiode is under high reverse bias voltage. So, the intrinsic region is fully depleted of carriers. When an incident photon has an energy greater than or equal to the band gap energy of the photodiode material, electron hole pair is created. Avalanche breakdown, it consisting of 4 layers: P plus I, P, N plus. Avalanche photodiode have high sensitivity and high responsibility over PI and diode due to avalanche multiplication. P plus layer subtract over the intrinsic layer is deposited. When a low reverse bias voltage is applied, most of the potential drop is across the PN junction. Charge carriers drift through the intrinsic region to the PN plus junction where a high electric field exits. Here, the multiplication of the carriers occurs by impact ionization. Impact ionization is highly accelerated electron in this region collide with the bound electrons of valence band and release more number of electrons free or conduction electrons. This effect is called the avalanche effect. Thank you.